Hello everyone. Today we are going to discuss a very easy problem, that is remove all adjacent duplicates in a string. Here the requirement is that whenever there is an adjacent characters that we see, we have to remove those characters and return the final string at the end of the day. So you just can't traverse over this entire string saying that okay, I'll remove b and b and that's it. No, you can't just check just for the adjacent values and thinking that that's the answer, because if we remove just b and b, we will see that we will be left with AACA, but our final answer is AA. Why? Because once BB was left, we were left with AACA, and where AA is also coming together, so we will remove AA as well. So I have if I have to explain you through some analysis, if I have to share, so we know that this was our string, right? We checked that okay, these two are together, so we will remove these two and we will be left with AACA. Here we will remove AA as well, because now these two values are together, and that's how we will be left with CA. Fine. Let's take one more example where our SA is equal to AZ XXZY. Same thing will happen. We will ignore these two because these two are together, and then once these two are left, we will see that Z and Z are also together, so we'll return AY at the end of the day, and that's what is returned here. Now you can't just traverse over this entire string thinking that this, if once I remove this will give me the final answer. So the better approach will be to use a stack, and what we are saying is we will insert A inside our stack. The next value we will get is B. I'm talking about this example. The next value we will get is B. Before inserting B inside the stack, we will compare, is this and the top value same or not. If they are same, then we will remove this value, saying that if I allow this B to come inside, that means these two will be the adjacent values which we do not want. So in that case, I'll pop out of the string. But right now we have B which is not equals to A. So as of now, just a minute. So as of now, currently we have A. We checked the next string and next character inside our string, that is B. Okay, we checked whether this B is there on the peak or not. It says no, it is not, so we'll allow B to insert. So now we are done till here. Now we reach to this point, and here we check again whether these two values are the value on the peak of the stack, is it equal to the value that we have currently? Yes, they are. So if I allow this B to come inside, that means there will be the adjacent duplicacy of values which we do not want, right? So in that case, what we will do, we will pop out this B as well, saying that we can't insert this, so we have to pop out this as well. So at the end of the day, these two values will get popped out. Now we will be left with now our next character will be A. So let me remove this value. So our next character will be A. Okay, now again we will check, is this equal to the peak element that we have with us right now? So it will say yes, it is. That means we can't insert this value, otherwise both of them will be the adjacent duplicate values which we do not want, and we can't have this value as well, because that's what it is saying, that we have to remove the adjacent duplicate value. So we will remove A as well. So right now our stack will be empty. We have popped out this and we have not inserted this value, and we are at C right now. So we will see our stack is currently empty, and the value that we have with us is C. So we will see that is the peak element equal to C, but we will see that it is empty, so we do not have to worry about it. We can just directly push, and the next character that we will have is A. We will again check if it is equal to the peak element or not. It is not, so we are allowed to push, and that's how we will push. And once we are done traversing over the entire string, we will now start popping out of the stack. So if you see, if we pop out, it will be AC, which is in reverse order, but we want CA, because that's how stack works, right? Stack works in such a format that the latest value that we have inserted is the one which will get popped out first, which we do not want. We want the first value, the last value or the oldest value that was inserted, we want that value to come on top. So we can either reverse the string that we get, or we can just use something that at the 0th index itself the value will get inserted. So we can use some techniques over there. So that's about the approach. Okay, let me go ahead and share the code with you guys. So okay, so here what we did, we initialized the stack. Once the stack was initialized, I am writing a for loop where I'm checking each character of this S one at a time. Okay, and I'm checking once I have the character with me, I'm checking that if the peak element is equal to if the just a minute, yeah, I'm checking if the peak element is equal to the character that I currently have. If it is, then we will pop the value that is there in our stack. But if that's not the case, then we will push this new value inside our stack. That's what we were doing in the example that we just saw. Once that is done, we will be left with the unique values or the non-repetitive or non-adjacent values. And we were discussing that we have to store them in reverse order. So either we can create a string out of it and then reverse it, or one more thing which we can do. The reason behind why I use a string builder was because if you take a string, and let's suppose our string is something like lead code, and you want to add a character, let's suppose S, to it. Okay, so if we just if it is just of type string, then it will traverse over the entire string and then S will get added. But this is not a good time complexity. Just suppose if your S is of some 1000 characters and you just want to insert one character at the end, so that will mean that you have to traverse 1000 number of characters just to reach at the end. So string is not the ideal solution when it comes to appending new values. That's where string builder comes in. I'm just talking about Java. For Python and for C++, you can see out that what is the most efficient way to add the characters inside the long string. So the reason, that's why I use string builder. I'm popping out all the elements from my stack unless it's empty. And when I'm popping out, I'm making sure I'm inserting the value at the start. This will make sure that the values are this will make sure that the string builder that we have will store the value in such a way that it will be automatically reversed. So if my stack have lead code like this, okay, then what I'm saying, pop out this value. So once we pop out this value, this will be my string with me right now. Okay, and next time when I pop out E, instead of adding E at the end, I'm adding E in the start. Similarly, once I pop out this, I'm adding this on start. Once I pop out this, I'll add it on the start. So I'll see that even though it was a stack, I was able to create a string which is in reverse order without doing the reverse thing. So that's what it is happening, and in the end I'm converting it into string. That's all. And if we talk about the space and time complexity, so the time complexity will be O of n, because at the end of the day we are just traversing over all the characters and we are just adding and popping out from the stack. So the popping and the removing out of the stack is O of 1 time complexity. And basically the main time complexity that it will take will be the traversing over the entire string, that is O of n. If we talk about the space complexity, then it will be again O of n, the reason being a stack. So in the worst case, there can be possible that there is no duplicacy of values, and if a string S name is leetcode, then all the values will get added at the end of the day, and that's how we will then pop out and all. But yeah, that's how it will work. In the worst case, our stack can hold of n time n values, so of n we can say. Similarly, string builder we are using, but let's ignore this because at the end of the day we have to anyhow use a string to save our values. So the main space complexity that will get impacted will be due to stack. So it is O of n. That's all. Thank you so much.